Okay, hello, internet viewership. We're here in the MIT Media Lab. I'm Tadge Dryja. I work at the Digital Currency Initiative here, and I'm sort of moderating a fierce but civil debate about ASICs, fixed costs, hardware, between James and David. You guys should introduce yourselves because you know more about yourselves than I do. James.
So I'm James Lovejoy. I'm a student at MIT. I'm a researcher at the MIT Digital Currency Initiative. For the last couple of years, I've been the lead developer of Vertcoin, which is a cryptocurrency that's based around creating an ASIC-resistant alternative to Bitcoin.
And my name's David. I've been a cryptocurrency researcher for, I think, 7 years now. And I'm the lead developer of Siacoin, a decentralized cloud storage platform that chose to embrace ASIC-based mining for its consensus algorithm.
Okay, so I guess that's sort of the idea of the debate is you're sort of anti-ASIC, you're sort of pro-ASIC, but of course there's a lot more to it than that. So for a quick amount of background, ASIC stands for Application-Specific Integrated Circuit. I don't think we're actually necessarily talking about ASICs themselves, but more generally in these systems like Bitcoin, Ethereum, Vertcoin, Siacoin, how easy it is to sort of perform the consensus work. And so all these systems use proof of work. And in the case of Bitcoin, initially you would just download the Bitcoin software, run it, and it would sort of make your CPU's fan spin up and you'd start generating Bitcoins. A year or so after that, people made GPU software, and that would, then you sort of needed a GPU to be able to competitively mine. And then a few years after that, they made specific chips where you basically needed to buy this chip because it's so much more effective. Whereas something like Ethereum, and I helped contribute to some of the algorithm with Ethereum's proof of work, where Ethereum needs GPUs. And so there's like CPUs, GPUs, and ASICs are kind of the three levels that we can talk about. Are there other things?
FPGAs is kind of in between GPUs and ASICs.
Do you know of any actual use of FPGAs?
To the best of my knowledge, no one's ever deployed a production fleet of FPGAs for now. Oh, no, just kidding. Baikal B. So there's a company called Baikal that released an FPGA miner for, I think, Sia, Decred, Library, Pascal, I think one other.
Blake 2 some-ish.
Yeah, and so their FPGA board was sort of optimized in size and memory for the ASIC-friendly suite of algorithms, and they're sort of the we can make FPGAs faster than anyone else can make ASICs, so we're going to own the market for 2 months before Bitmain steps in.
Okay, so there may also be FPGAs. There's also stuff like Bram's working on Chia or whatever, where it's sort of like hard drive based proof of work essentially, but that's not quite in full deployment yet. But looking at it, the main debate is okay. Well, do these ASICs? We can at least agree on what ASICs do is that they raise the entry costs and the sort of capital costs relative to the operational costs, right? Like if you're using your CPU, you're gonna use more electricity and less your initial investment. And if you're buying ASICs, you're gonna be spending more money on that equipment and less on the electricity over time. Is that? Can we agree on that sort of?
Kind of. The big thing about GPUs is that if the coin goes to garbage and it's not worth anything anymore, you can take a GPU and you can use it for something else. There's a big secondary market for GPUs because gamers like them, but also AI shops use a ton of GPUs and a lot of research related stuff uses GPUs, and so GPUs don't have this even though the catbacks is pretty high to set up a GPU mining farm, if the coin disappears, your GPU mining farm is not a pile of metal. It's a bunch of computational hardware that you can throw at another problem and still it still has value.
Yeah, and so just for people, CapEx and OpEx are two terms we're going to use here a lot, probably because capital expenditure and operational expenditure. In our cases, OpEx is basically your electricity bills, and CapEx is basically the bills for all the equipment you're going to end up buying. And so having low CapEx, I don't know, there's probably disadvantages and advantages. I remember mining Bitcoin in 2011. It was really fun. I didn't have to buy anything. I just sort of let my computer run, and then my electricity bill went up by like $5, and I had like $2 worth of Bitcoin. And so it wasn't necessarily the best deal because I had high electricity prices, but it was like easy access and easy entry into the system, and I think a lot of people got interested in it. But long term, it wasn't viable, at least in Bitcoin's case. So okay, James, like, is that one of the things you like about it?
The key difference is like permissioned versus permissionless systems. I mean, in my mind, if you have, at least the way the system's constructed now, ASICs in a system effectively makes it permissioned because you need to be friends with Bitmain in order to get the latest hardware so that you can actually be a meaningful participant in consensus. Whereas with GPUs, because they're so general and they're everywhere, and they've been sold for years and they're in every computer store, my propensity to contribute to the system in a consensus fashion is not limited by anyone else because I can buy a GPU equally to David can buy a GPU, and Jihan can probably buy a GPU.
Mm-hmm. And so, what would you like? Do you think that makes it more permissioned, or?
So I think in the situation we have with ASICs today, that is more correct. I think in the idealized situation, that wouldn't be the case. At the end of the day, when it comes to most coins, and James, what brand GPU runs best on Vertcoin?
NVIDIA.
There you go. So at the end of the day, if you want to mine Vertcoin, you have to be friends with NVIDIA. The difference between NVIDIA and Bitmain is that Bitmain is really choosy about who their friends are. They're this really aggressive monopolistic party, and NVIDIA is like really happy to sell GPUs to whoever wants them and for whatever reason, and they've sold a ton of them for a lot of reasons. And so you don't get away from this when you pick ASIC resistance, you don't get away from this having to be friends with a single dominant company game. It's just that in today's environment, the single dominant company that you have to be friends with is a lot friendlier in the GPU world than it is in the ASIC world.
But I guess the key is that it's not specifically about GPUs, it's just about generalized commodity hardware. So if you could do this with hard drives or CPUs in a way that couldn't be like botnetted really easily, then you could not use GPUs and use something else. And the reason why you have to use NVIDIA on Vertcoin is simply because the optimized miner to make it run on AMD is like hard to write and costs lots of money to achieve. So eventually it will be the case that you can mine on both, and different currencies have different profiles.
I would
GPUs
actually argue that the chip architecture on the NVIDIA cards is just inherently
but though
more prepared for the problem.
Yeah, right now there's an orders of magnitude difference between AMD and NVIDIA
Really?
in terms of the speed. Yeah,
I did not know that.
But once the miners are improved, it should be maybe like 10 or 20% between them. So it's not so bad.
So one question then. Okay, so we're talking about GPUs versus ASICs. Have there been CPU targeted algorithms? Because I know, like in the case of Litecoin. Okay, so really it was Tenebricks, right? Where the guy said, okay, I'm going to make something that's CPU mined, and you can't make a GPU being able to mine this. And then Litecoin sort of took Tenebricks' code and marketed it a bit better and became Litecoin. And initially it was, hey, you can't use GPUs. And that lasted, 6 months. And then people made a GPU miner for Litecoin because they use scrypt, but they have like n equals 1, so it doesn't actually need much RAM. And the idea was, okay, not only can you not do ASICs, you can't do GPUs. Both of those things, I think, fell eventually. So to some extent, it's non-trivial to make a ASIC-resistant algorithm. On the other hand, it seems like it's working fairly well. So something like Ethereum...
I would argue against that.
Well, okay, wait. It's working better than, say, Tenebricks did. Ethereum has not... There's no ASIC, right?
There are no ASICs for Ethereum that we are publicly aware of.
Okay.
Which I believe it's extremely likely that both Hailong and Bitmain have Ethereum ASICs either completed or on the way. Bitmain,
So,
I would
yeah.
say, is very likely that they're running.
Okay, so maybe let's.
Lot of hash
I mean,
rate.
we don't have any evidence, so we probably
Right.
shouldn't get into like conspiracy theories. But let's say, for argument's sake, there was Ethereum ASICs, and they're coming out sometime this year. That's still pretty good in terms of like number of years it resisted ASICs,
That's
right? So it's sort of like you want to make like anti-piracy consoles or something. Like it's a losing battle, but hey, if we can have a market for 3 years where this console can't have pirated games, that's probably good enough for the manufacturer to be like, hey, we're going to recoup our costs. So you could say like, well, ASIC persistence, it's not permanent, but if you can buy a couple years with no chips, that's pretty good. But have CPU only algorithms have been successful? Have people tried to build those, or does it always go to GPUs?
Yeah, so at least when Vertcoin first moved from like scrypt n, like n equals 2, because an ASIC was produced for Litecoin, which could also mine the higher n value scrypt versions, we created a version of our current algorithm which was almost like proportionally equally powerful in CPUs and GPUs versus their like power and fixed cost. The problem with that is lots of people have botnets that are very effective. And so they can, not quite 51% the network, but take up a large proportion of the hash rate compared to people's GPUs, so they can't participate. So, and Monero currently has this problem as well, where it's like mined quite heavily by botnets. So eventually we readjusted the algorithm parameters so that it favored GPUs over CPUs. And that seems to have worked pretty well. You find that the marginal profitability, so this is like dollars per mega hash per second per day, has stayed pretty much constant proportional to the cost of the hardware and the cost of like global electricity.
So botnets, basically some kind of virus, some kind of malware takes over lots of computers, and then people would sort of have their computers be unsuspectingly mining for some coin or another. And I guess that, like, on the one hand feels bad because you're like, oh, I'm sort of contributing to like viruses and like malware infecting people's computers. And I guess it also has other problems for the networks.
Yeah, so it pushes down the profitability for everyone else. Theoretically, it's bad for the security, depending on how big the network hash rate is. And just generally moving forward into the future, like assuming these systems are going to be based around fees, egalitarianly speaking, you want all of the fees to go to as many people as possible and be fairly distributed rather than going to, one botnet operator who's using a bunch of people's computers illegally.
Okay, so obviously ASICs, you really don't have to worry about botnets. Everyone who's buying an ASIC is making sure that they're operating. GPUs, is there any? I mean, is it like something that happens?
As far as I know, the problem with GPUs is they're like incredibly hard to configure from like a host code perspective, and I think most viruses are probably delivered via like JavaScript these days, and JavaScript is not allowed to interact with GPUs in a way that.
So at least right now,
until there's like WebCL or something that allows you to do web-based GPU computation, then I think it's not a problem.
So it's not necessarily that the distribution is more concentrated, it's just that the way software works right now, it's harder to sort of get GPU drivers running. And where with an ASIC, you need actual hardware and some kind of host machine to sort of communicate with the ASICs usually, right? Or is that, like, so in the cases of something like Siacoin, what's the actual setup? Do you have physical hardware people buy, or is it like a PCIe card, or how do people?
So it's typically, it looks like an S9. It's a box that you buy, and it's got an Ethernet jack and like a power switch. And then when you plug it in, it announces itself over localhost on a certain port. If you ping it, it'll have like a config thing. You can put in a pool address for it to connect to. Then it just starts mining. So it's super minimal, and you need some host machine on the network to talk to it.
And so for GPUs, you generally put one or multiple.
Yeah, so a machine might have like 6 cards associated with it. And at least in the Vertcoin model, you run like P2 pool, which is like a distributed pool, and then people connect to that using each individual miner.
And so I guess both of these setups are, not really trivial. It's not like you just go to the store and buy something.
Well, I mean, if you already have a GPU in your computer, like you're a PC gamer, then again, at least with Vertcoin, there's like a miner that you download.
So, but it's somewhat sophisticated. Like there's a little bit higher bar in terms of technical sophistication than using a web browser.
Yeah.
For both of these. Okay, so in terms of these coins, like what about the Bitcoin ecosystem? I guess we could look at. So in Bitcoin, it was SHA-256. There was probably not a lot of concern for ASICs, GPUs. It wasn't something people thought of in the very beginning. And then Satoshi has posts where he's like, hey, can we have sort of a gentleman's agreement where we don't make a GPU miner? Which worked for like a few weeks, I guess. Because people are like, hey, there's money, I'm going to do that. And so the current setup is, I guess I'm not as familiar, but like, you definitely need an ASIC. How competitive is that landscape? And like, where are people mining?
The Bitcoin world is extremely competitive. If you're paying more than, I'd say, 7 cents all in, so that's electricity, that's property tax, that's rent, that's staff to run around and replace broken machines, that's maintenance, everything, all in, you're paying more than 7 cents a month, 7 cents per kilowatt hour, which translates to about $50 per month per kilowatt of hardware that you have. You're basically not going to make any returns. And Bitcoin is at the point where you can't really buy a consumer, even if you were to buy a consumer miner, there aren't any good ones on the market. And even if there was, you'd probably half the ticket price of that consumer miner you'd never make back. So you'd buy it knowing that it's going to be a loss. Because your electricity is too expensive. The industrial miners are extremely loud and they're extremely loud, extremely hot. They consume pretty much as much electricity as a home circuit has. And if you go down to a smaller miner, what we've discovered is that you end up paying like 60 to 100% more per hash rate to get these smaller, like home-friendly miners. And so basically, if you want to ASIC mine, you're going to have to do it at an industrial scale, which means you're going to have to make returns, which means you're going to have access to cheap electricity. And there's a short list of probably like 20 regions in the world with electricity and climate conducive to competitive mining.
Wow, that sounds so not something you can do in your backyard.
No.
Is GPU mining?
Yeah, and the difference with GPU mining is, at least for the last year, like GPUs typically are like return on investment in around 150 days. They don't have this ridiculous increasing returns to scale profile where as soon as you go past, as you say, an industrial scale, it becomes like exponentially cheaper to run it. In this case, the returns to scale are marginal in terms of the discount you'd get for bulk electricity purchase and the discount you get for bulk hardware purchase, which are a few percentage points rather than
so are there sort of warehouse level GPU mines?
I'm actually going to push back on what you're saying. I think consumer GPU mining profitability is a function of two things. The more important one is that the price of GPU mined coins has gone up massively. And so if you're going to make an industrial mine, it's going to take you, if you're really fast, it's going to take you 4 to 5 months to set up. If you're average speed, it's going to take you 9 to 12. And if you're slow, it's going to take you like 15 months. And so the price has gone up recently enough that industrial GPU mines are only just starting to catch up to the price raises. And so I think that over the next year, especially if the price flattens out, we're going to see the GPU return times or the ROI times for GPUs on home equipment go way up. And then the other thing is that home consumers tend to completely ignore the cost of the electricity, and so they don't realize that running a GPU nonstop is costing them $40 a month, and so their 150 ROI time they've spent actually 75% of their ROI on electricity, and they don't factor that in.
Well, that ROI figure I quoted does actually include the power costs roughly for sort of like the cheaper end of the US, but
okay.
Yeah. But I think also on your point, like the hash rate, because people can essentially move what is effectively their labor with GPUs between coins, the hash rate has has a far higher propensity to scale with the price. So what you find is that this marginal profitability rate doesn't change much within a range. It may change by a couple of cents, like per mega hash per second per day. But you find that the actual like dollar value profitability stays roughly the same irrespective of what the price is doing because the hash rate adjusts.
And that's because I guess with one GPU you can mine any number of coins, any number of different algorithms.
And then when you give up, you can go and sell your GPU and get most of the value.
Whereas with a specific ASIC, generally there's not a lot of, or are there? Like if you have, you know, whatever chip, are there multiple different coins you can mine with that, or is it generally one or?
Generally speaking, every chip has one dominant coin. You know, there are a bunch of coins that you can point ASIC miners to. But if the Bitcoin price falls in half, it does not matter what the rest of the prices do. Your ASIC profitability is going to fall in half because Bitcoin is basically the only relevant factor, and it's the same for Litecoin, for Siacoin, will be for Tcred.
How many different ASIC model? I mean, is it basically There's like SHA-256. There's scrypt. Are there like a variety of different ASICs?
Yeah,
like X11.
So there's Bitcoin, there's SHA-256, there's Litecoin, which is scrypt, there's Dash, which is X11, and for a while those were the only three. Checking. Pretty sure for a while those were the only three. Then now there is Siacoin miners, and there are Dcred miners, so that puts us 5.
Dcred is also Blake?
It's Blake 256.
Okay, so a different
Which
yeah.
It's different enough, unfortunately, that making an ASIC is basically like ground up, complete from scratch, more or less. And then the conspiracy rumors is that you have ethash miners that exist, but because it's a ASIC hostile network, they stay in secret. You have equihash miners, which I think is a very, very strong bet.
For Zcash.
Yes. So for Zcash, I think extremely likely that there are, beyond Bitmain, there are probably several companies mining Zcash in secret.
Yeah. So that might be something.
And then Monero as well.
Okay. To sort of an interesting aspect of ASIC production is you see a lot of vertically integrated companies, and I sort of remembered looking at this, and like 2013 when the first Bitcoin ASIC started coming out, the like incentive problems with these systems seemed pretty egregious, and like every ASIC company seemed like kind of really bad. Because the way I thought of it is like there's a company saying, hey, we built a machine that prints money, and I'll sell you this machine for some money. And it's like, well, how much is it going to print, and how much do I have to buy it, to pay you to buy it? And if it prints $100 bills and you want $500 for it, it's going to print at least like 6 before it breaks, right? Like, well, how do you know? So it seemed that like a lot of times you've got a company selling something that pretty directly generates cash for cash, and that there's all sorts of incentive problems and knowledge problems where like they, market for lemons kind of thing, where like they know how much this is going to make, and they're going to sell it to you for twice as much as it's going to make, kind of thing.
That's a stunt Bitmain has pulled, at least with Dash. What they did was they made more Dash miners than could possibly make returns, right? Then they sold them all simultaneously. So nobody knew how many they sold. They just sold a bunch of batches. And then when everything was delivered, the difficulty went way up. Most people never made any money back. And Bitmain, who sold all these at margin, had more profit than they would have made just by owning 100% of the hash rate.
Well, that's almost like sort of fair seeming compared to some of the things like Butterfly Labs, where they built the hardware and then we have to test it, and so they like mine with their own hardware to quote unquote test it and make most of the profit before actually shipping out to customers, things like that.
I think Bitmain actually does that as well. Most of the S9s that you get from Bitmain are shipped used.
Anyway, there's incentive problems where
for sure.
It's not even like maybe regulation would help, but you can sort of see that like a totally free market with these ASICs, there's all sorts of weird problems, right?
If you have to regulate it, that seems to like defeat the whole point of the system in the first place, right? Which is that it's like permissionless and you don't need any authorities to like help it.
Right. Well, so that's a good question. What are the authorities? So in the case of Bitcoin,
before we leave that point, I want to say that I think these problems are also endemic to GPU mining, but we haven't seen that yet, because in ASICs it was sort of each chip is like its own green field, right? And so like most greedy company can come in and mess around. With GPUs, it's not a green field. You got NVIDIA and AMD who are sitting there. But if these coins grow up, to market caps where it makes sense to say make entire fabs or foundries to manufacture GPUs for cryptocurrency mining, you're going to be in the exact same position where you're going to have the same incentive problems.
Yeah, so that's an interesting point where you're using the fact that you're somewhat of a small fish in a big pond because you're using GPUs. If you get big enough, well, you start, and we have seen that, especially in the last year with Ethereum and GPUs. And I just know walking around in Micro Center, every time I pass by the GPU section, people complain about Bitcoin, and I'm like, well, it's not actually. I don't say anything, but it's mainly, I think, Ethereum mining and a lot of the other altcoins. So Ethereum's a good example, probably Siacoin, Vertcoin that you guys have experience with, but sort of the role of developers. And I know with Ethereum, one of the things is they've said for a long time, we're going to move to proof of stake, and we don't want ASICs, and we sort of have a threat that if there are ASICs, we're going to either change the algorithm or get rid of proof of work entirely. Yep. So in Ethereum's case, it's been somewhat effective. In the case of Vertcoin, like changes to proof of work functions are generally hard forks. There's probably some sort of marginal ways to do it with soft forks, but it generally is a hard fork, and that's a big coordination problem. Something that like Bitcoin may not be able to do that well.
Any fork where the majority hash rate doesn't follow you is a hard fork. So it's a hard fork to change proof of work if your miners don't consent.
I mean, even if they do, you have to update to your software. Mm-hmm. Like from the technical definition, it's a hard fork in that it's not compatible with your old software generally. You could maybe bake in hard forks, but bake in different. Okay, at this block height, change the algorithm. But so how like sort of pre-planned are these things versus how reactive it is? So in the case of like Vertcoin, it's changed. In Siacoin, has it changed or reacted to the market? Or?
When Bitmain announced, so there's a big community ASIC project. One of the big confounding factors there was that I'm the CEO of both the ASIC project and the company that does most of the SIA development. Mm-hmm. So there's this big conflict of interest. And so when Bitmain's ASICs got announced, immediately I was unable to act freely as the lead dev of SIA because everyone was questioning my motivations. And so internally, a lot of the core community felt that changing the proof of work. So what we did with our ASICs was that we added a little extra circuit to our chip so we could hard fork the proof of work. It's a subtle change, and there are many like such potential changes. So it's very difficult to anticipate what that change might be. And so even if you know that we're doing this, you as Bitmain or as a competitor aren't going to be able to write that circuit into your chip. And so we have this option to invalidate all ASICs except for
some little thing where in round 30 of this hash function, flip a bit right here, and if that's in your circuit, you're not going to really be able to.
Right, and if it's not in your circuit, your hardware is completely useless. So of course the problem there is that if we decide to do that, we essentially entrench Obelisk as the single monopolistic one hardware provider to the side defense scheme, which is has issues with it itself. And so when Bitmain had announced, we as a community, one, were caught very much off guard, and two, hadn't properly navigated all the incentive stuff and how do we make sure that it doesn't become the one obelisk to rule SIA. And because of that, in the moment there was just too much pressure, and we weren't confident that we could fork and also protect the long-term incentive scheme. And so ultimately we didn't fork. We decided to embrace Bitmain ASICs, and so a lot of we'll see. But there's an enormous amount of turmoil.
Sounds like a mess, yeah. So is Vertcoin also a mess in terms of
I mean, a lot of the logic, I guess, is the same in the sense that the algorithm is designed to be easy to change in a way that's like trivial in software, but catastrophic for the ASIC implementation. So for our miners, all we have to do is like update the miner software and they're good to go from that point. So I guess we have like not the same problem as you, because in the sense if you had forked to, or announced that you're going to fork to like nullify the Bitmain ASIC, you have a bunch of community members that potentially also bought the Bitmain ASIC. You would be saying to them like, you know, you can't have this ASIC, but you can't have this ASIC, even though you've spent money on it.
That was actually the worst thing. I think the dirtiest thing that Bitmain did. They announced and opened their sale in the same moment. So there were no Sia ASICs, and then 8 minutes later, consumers had bought $20 million of Sia ASICs. And so the dev team had $20 million of upset community members before we even knew that something bad was happening. And so that, like, again, yeah, it was awful.
It's a really difficult situation, and I'm glad I'm not in your position in that sense. But I guess there are two types of forks. Like the first one that we did, you know, we had like a few months of lead time because they announced that this ASIC was coming, and so we knew like what we had to do ahead of time, and so we were able to create the things in time and hard fork pretty much before the ASIC had even come online. The second time with respect to the botnet, that was entirely reactionary. So like one day you wake up and you see, oh, the marginal profitability is like reduced by a factor of 10, like what's happened here? And it's because there's one big miner that's mining at a way cheaper rate than everyone else.
And so you could sort of see that there's one miner which was, you know, came out of nowhere.
It's clearly not expending any funds in order to like do this mining.
Because it seemed irrational. It's like no one could be paying that cheap electricity price.
But I mean, there are botnets, so they're paying nothing, right?
Okay.
So
was this botnet sophisticated in that it was like not super clear that it was a single mine? I mean, because sort of from my thinking in the initial Bitcoin code, it's all anonymous, right? The whole idea of mining is that you don't have to say anything about yourself. You just sort of have this hardware, and that's your proof. And yet, one of the first things people did is they said, "Hey, there's 32 bytes here. I can put my name there." And so they start putting their name and like emojis of fish and things like that or selling it as ad space in this 32 byte field. And so it was always seemed weird that miners were so well known, and that you'd sort of have in Bitcoin or other coins, you have like a really good data about who's mining what. So in the case, even with a botnet, were they?
Yeah, they were mining to just like one address.
They didn't get okay. So no.
Yeah. And I mean, clearly it clearly wasn't sophisticated enough because they didn't like make any efforts to stop us that I can see. Although when it came to SegWit activation, someone was spending a crazy amount of money renting hash rate to prevent that from activating. So there are still like
interesting. So renting, I mean. I know in GPU world to some extent, because I've done this myself. I forget, this was like Waffle Pool or something a couple of years ago, where I had a GPU, can't mine Bitcoin, but hey, I can sort of mine something, and someone will pay me actual Bitcoin for it. Sounds good to me, and I have no idea what my GPU is even doing, but I get Bitcoin. And I guess NiceHash is like that. Is there similar markets with ASICs, or is it more? You know, you buy it and you're running it yourself.
Not yet. I hope we see that.
So you do exist. NiceHash does provide that service. It's just not, the liquidity isn't as high as it is with GPU mining.
Right now, ASICs, I think, are all about vertically integrating. And so the idea of renting out hash rate to someone who wants to borrow it, it's just like, well, what could they do that I can't, right? And so if they're making money, that could be money that you make instead. Yeah, it does very interesting things to the incentive schemes because you go from this situation where the only thing your ASIC is good for is protecting the network to wondering, are there additional ways to make money with the hardware?
Yeah. So can you explain a little about NiceHash that you guys had?
Yeah, I mean, NiceHash was an interesting.
So just how did NiceHash work?
It's like a proxy for mining. So rather than, like you say, like mining the coin directly and getting the coin that you're mining, you essentially give your hash power to NiceHash, and they direct it as they see fit to their customers who are buying hash rate from NiceHash. and then pay you per share in Bitcoin. So from the perspective of the miner, you essentially get no variance in your payout, maximum possible profitability. And from the perspective of a purchaser, you don't need any hardware, and in return you get what's probably a slightly less than profitable rate for the hash rate.
But you also eliminate, so you're also moving who's paying for CapEx versus OpEx.
Yes.
And you say, okay, I pay for all the CapEx, and yeah, I am still paying the electrical cost, but I'm getting subsidized directly. And someone else can say, okay, well, I'm just sort of hiring out all this hardware to do whatever mining I'd like.
I mean, a system like NiceHash causes really bad, I guess, structural risk within the system, because when NiceHash was hacked and it got shut down, you saw instantaneously, at least the Vertcoin hash rate dropped by 90%. As NiceHash went offline, because clearly that's where everyone was getting that.
So
hash
everyone
rate.
was sort of pooling
And
through.
the hash rate still hasn't recovered from that. So, at all, it just dropped and stayed low. So, I mean, maybe
So the switching costs, I guess, were very high.
Yeah, so there's clearly like a lot of inertia. Like the problem with NiceHash is they made it so easy from a miner's perspective and so easy from a user's perspective that everyone was using them because setting up for yourself was just too hard.
And ultimately, it was sort of centralized, custodial, and they had everyone's money. And,
And they lost everyone's
that
money.
generally ends in one way in this.
Yeah,
industry.
well, they lost like $60 million or something, right? But
So
it's a problem with also ease of use.
okay, so that's we should talk about pools. That's sort of a meta pool in something like Sia or other ASIC coins. Are there pools, or is it generally sort of owner operated?
There are pools. I think, this is often conspiracy land, but I think pools are mostly a farce, and that most of the hash rate is in like one place, but they put it in like 5 pools so people don't freak out.
Okay, so it's sort of like minor laundering, where it looks like you have competition, but really it's all one entity.
I think there's a lot more of that happening than the graphs might indicate. And we did see an interesting thing that I think actually has another explanation now. But at one point, the Sia network, across all the pools, the hash rate just dipped by like 35% simultaneously. And you're like, but actually, I think that's just a fault in the A3 mining hardware. I think that occasionally it hiccups and just loses hash rate, but they like all hiccup together.
So we can maybe explain. So the idea of pools anyway, initially. So in Bitcoin, for example, initially you would have to solo mine, where you would download the software, run a full node, and just start churning away at SHA-256 and see if you find a block. The problem I guess people had with that was variance, where once you become a very small portion of the network, the quantization error becomes very high, in that you might not find a block for a month. And if you expect 1 block per month, maybe 1 month you don't find anything, maybe 1 month you find 2. It's like an enormous amount of variance. And one aspect of that is in Bitcoin, well, a block comes out, you get about 144 blocks a day. Most other coins have more frequent blocks, right? So the pressure to pool is somewhat less, but still pretty high. So the idea of a pool is, okay, well, everyone sort of pool together, prove that you're doing work, but haven't quite done enough to find a block. And I'll pay out based on how much effort you've put in. But the actual rewards from the block go to the pool operator.
And beyond that, pools generally offer a little bit better like uptime stability and much better orphan rates. Usually pools will have much lower orphan rates than solo miners will, because they wrote very special code and they all know each other and they all connected together to make sure that the pool ecosystem is much more competitive than any solo or peer-to-peer ecosystem.
Yeah, so that's another problem, is that just orphans happen when, among other, the main reason you'd have an orphan is when 2 blocks are discovered very, very similar times, and one of them has better network connectivity. That's going to be the first seed, and that's going to tend to win out and orphan out the slower one. So yeah, so you see a lot of mining pools peer together, or lease dedicated links, or at least have servers in different data centers where they can optimize for ping times and things like that.
You also have things like P2 pools, so you have distributed pools that use, I guess, like a second layer blockchain, effectively like a sliding window blockchain, to determine what the payouts are. And at least now that NiceHash has gone on Vertcoin, that's like the #1 pool. So you can have a system. Yeah, so you
that
can
might be the first example of P2 pool being preferred by
so
anyone
it fluctuates between like 25 and 40% of the network hash rate. So
that's actually
so,
something to be proud of.
But what I've discovered is it's a problem of like making it easy to use. People they drift towards NiceHash and they drift towards centralized pools because they provide a nice web UI and it's like this big man's taking care of me and everything.
Well, not just that, but just the costs, the sort of developer costs or time costs, where there's a lot of people who may have thousands of dollars to sink into buying equipment or paying for electricity, but if it takes a day of their time, that's unacceptable. And I know tons of people who that keeps happening, where you look on the blockchain and you see exchanges and you're like, they're overpaying by millions of dollars in fees. And you could hire me, I could probably fix this in like a day or two. You can pay me, but just the coordination costs of these things are so high that you see things where if it's easy to use, has a nice interface, even if you make less money, people will all go to that kind of thing.
And they won't even know that they're making less money in most cases. They will just see that as the first option and be like, this is good for me.
Yeah, so how rational people are in terms of profitability. I have seen, so I don't mine much now, but I've known people who mine. I know one guy who bought $10,000 worth of mining equipment for Bitcoin when the price of a Bitcoin was $1. And he probably did okay, but I'm pretty sure he didn't get $10,000 worth of Bitcoin. And so in a lot of cases in Bitcoin, it would have made just more sense to just buy some coins. And so I guess sort of, to close out, what would you recommend for people who, are interested in getting into these things, either with ASICs, either with GPUs? How can people learn more, or if they want to participate, or learn not to participate, or what are some resources here?
I mean, I'm not so familiar with the ASIC world and how you would the practicalities of how you would actually go about getting one, but at least from a GPU perspective, mining Vertcoin is really easy. We have a one-click miner that you can go and pasting something and clicking is pretty much the process to start mining.
And are other coins similar, or other sites?
Yeah, so there are other things, but generally they require a little bit more configuration. Again, it's this problem of if you want to mine, it's not geared towards usability, it's geared towards you already understand how to do computers, so you know how to configure it.
And what about Sire ASIC type kind of things? What would you recommend? Stay away from it, buy shares in a mining company?
What shares?
Well, not cloud mining.
Yeah, I'm going to say if you're a home consumer, my general advice is probably to stay away from it, unless you're comfortable losing a little bit of money, because if people are at home losing money on mining, that slims out people companies like Bitmain. Their margins slim and they have less wiggle room to do destructive things. And so I generally see home mining as a very good thing, but don't expect a ton of ROI on it.
So it's somewhat altruistic in that a non-profitable home miner does help to secure the network by reducing profitability for sort of large centralized entities.
And then the other thing that you can do is co-location mining, which is something Obelisk has set up very carefully, is that if you buy a miner, when you buy it, you can pre-select a bunch of data centers and say, ship it here, let them take care of it. And so my hash rate is going to be in a data center in Sweden, where
But do you have any? So I know we can sort of finish up, but cloud mining is, to me, always seemed pretty perfect for pyramid/Ponzi kind of schemes, where you say, give us your money, we'll give you maybe more money, probably less money. And there may be mining involved, or it might just be nothing.
Yeah, I mean, there's one project now that has an app, and you mine through the app, but really they're just paying you out of their marketing funds.
Yeah, so there's trust in cases where you're not holding the physical hardware. Trust can be an issue. So is that something you're looking at
it's
with
something
co-location?
we're wary of, and something that we try to vet our colo centers to make sure that they're a real thing. We know that they received real hardware, for example, because we sent them the hardware, but you don't know that we sent them the hardware.
Right.
So yeah, I mean, if you just assume that no one is going to be abusive, there's a very practical business reason to do cloud mining as a cloud miner, which is you may not have the catbacks to buy all the hardware. That's really expensive. If you cloud mine, that's essentially fundraising.
Yeah. But if you assume no one's going to be abusive, you may not need, cryptocurrencies or maybe even money at all, and everyone can just get along. And that could be our next strategy. No, just sort of get along and share free moneyless economy. Okay, so I think we're going to wrap it up. Any last comments from either guys? Pretty interesting stuff.
Yeah, let's keep cryptocurrency free and permissionless and allow people to participate.
So let's make ASICs for Vertcoin.
We'll
do it in secret.
You can
So,
you can try.
Cool. Okay, thanks.